At first glance, a magnet seems like nothing special, just a simple piece of metal. It doesn't glow, move, or make a sound. Yet somehow it can pull or push other objects without even touching them. This mysterious power has fascinated humanity for thousands of years. It's one of the fundamental forces of nature, magnetism. If you enjoy this educational content, please give a like, subscribe, and share this video with your friends. To truly understand how a magnet works, we need to dive deep into the atomic world. Every magnet, no matter how big or small, owes its power to the behavior of electrons inside atoms. Electrons are tiny charged particles that orbit the nucleus and also spin around their own axis. Whenever an electric charge moves, it creates a magnetic field around it. That means every atom is, in a way, a tiny magnet. In most materials, the direction of these atomic magnets is random. Their individual magnetic fields cancel each other out, and the object as a whole shows no magnetic effect. But in certain metals, like iron, nickel, or cobalt, something remarkable happens. Their electrons can align in the same direction, combining their tiny fields into one strong, unified magnetic field. This phenomenon is called ferromagnetism. You can imagine it like a vast army of tiny compasses. When each one points a different way, there's no effect. But when all of them turn the same direction, their collective force becomes powerful enough to move objects from a distance. Every magnet has two poles, a north pole and a south pole. The magnetic field flows outward from the north pole and returns to the south. And here's a simple rule: opposite poles attract, while like poles repel. If you bring two north poles close together, they push away. But a north and south pole instantly pull toward each other. And here's something even more fascinating. No matter how many times you cut a magnet in half, you will never get a single pole. Each piece will always form a new north and south pole. Scientists have long searched for the mysterious magnetic monopole, but so far none has ever been found. You can actually see magnetic fields in action using iron filings. Sprinkle them around a magnet, and they'll align themselves into elegant curved patterns, the magnetic field lines. These invisible lines map the shape of the magnetic force surrounding every magnet. Magnetism, though invisible, is everywhere, in motors, computers, credit cards, medical devices, and power plants. It's not just a physical curiosity, it's a force that makes modern life possible. Every magnet, no matter how small, is surrounded by a magnetic field, an invisible region of influence that extends into space. We can't see it directly, but we can observe its shape with a simple experiment. If you sprinkle iron filings around a magnet, they instantly align along elegant curved lines. These lines, called magnetic field lines, flow from the magnet's north pole and return to its south pole. The closer the lines are, the stronger the magnetic force in that area. But where does this field actually come from? The answer lies in moving electric charges. Every moving electron generates a magnetic field around it. In atoms, electrons orbit the nucleus and also spin around their own axis. Both motions create magnetic effects. In most materials, these tiny magnetic fields cancel out because the electrons point in random directions. Yet in ferromagnetic metals like iron, cobalt, and nickel, the electrons can align in the same direction, combining their forces into a unified field. This same principle operates on a much grander scale, not just in metals but in planets, stars, and galaxies. In fact, our entire planet Earth is a gigantic magnet. Deep beneath our feet, the Earth's core is made mostly of iron and nickel. The inner core is solid, but the outer core is a hot, swirling ocean of molten metal. As this metallic fluid moves due to Earth's rotation, it creates electric currents. And since moving charges produce magnetic fields, these currents generate the geomagnetic field, the magnetic shield that surrounds our planet. This process is called the geodynamo. It's what powers Earth's magnetism, and without it, our world would be dangerously exposed to space radiation. The Earth's magnetic field stretches far into space, forming a protective bubble known as the magnetosphere. It shields us from the solar wind, a powerful stream of charged particles flowing from the sun at speeds of millions of kilometers per hour. Without this shield, the solar wind would gradually strip away our atmosphere, just as it did on Mars. Without it, there would be no oceans, no air, and no life as we know it. But Earth's magnetic field isn't constant. Throughout geological history, it has flipped many times. North becomes south, and south becomes north. This phenomenon, called magnetic reversal, happens every few 100,000 years. Scientists have found proof in volcanic rocks. When lava cools, tiny magnetic minerals inside it align with Earth's magnetic field, preserving a snapshot of its direction at that moment. Our planet isn't unique in having a magnetic field. Jupiter, Saturn, Uranus, and Neptune all have powerful magnetospheres. Jupiter's is the strongest, more than 20,000 times stronger than Earth's. Even the Sun has a magnetic field that twists and fluctuates, creating sunspots, flares, and massive eruptions that send waves of charged particles across the solar system. When those charged particles collide with Earth's magnetic field, they spiral toward the poles and interact with the atmosphere, producing one of nature's most beautiful phenomena, the aurora, or northern and southern lights. It's a breathtaking display of glowing colors in the sky, proof that magnetism is not just theoretical, but alive and visible. So the next time you use a compass or watch the aurora borealis, remember, you're witnessing the power of the magnetic heartbeat of our planet, a force that protects all life on Earth. Magnetism isn't just a natural curiosity, it's one of the foundations of modern civilization. Without it, there would be no electricity, no computers, no smartphones, no internet, and no engines. Every time you turn on a light, start your car, or listen to music, you're using magnetism, often without realizing it. The connection between electricity and magnetism was first discovered by Michael Faraday in the 19th century. He noticed that when an electric current flows through a wire, it produces a magnetic field around it. And when that wire moves through a magnetic field, it generates electricity. This simple, elegant relationship, known as electromagnetic induction, became one of the greatest discoveries in the history of science. Thanks to this principle, humanity learned how to generate electrical power. Inside every power plant, giant coils of copper wire rotate within powerful magnetic fields, creating electric currents that light up our homes and cities. That's how every light bulb, every socket, and every computer is powered, by magnets. But the story doesn't end there. When electricity and magnetism work in reverse, they create motion. This is how electric motors function. When current flows through a coil inside a magnetic field, it experiences a force that makes it spin. This is the basic mechanism behind everything from electric cars and fans to washing machines and industrial robots. Magnetism turns electricity into movement, and movement back into electricity. It also brings sound to life. In every speaker or headphone, there's a small electromagnet attached to a thin membrane. As the electrical current changes with the sound signal, it causes the membrane to vibrate, creating the sound waves we hear as music or speech. Magnetism even allows us to store and access information. Hard drives in computers use tiny magnetic regions to represent 0s and 1s, the building blocks of digital data. When you save a photo or a video, you're literally magnetizing microscopic particles in specific directions. Even your credit card uses magnetism. That dark stripe on the back contains magnetic particles arranged to store your personal data. And in medicine, magnetism saves lives. MRI scanners, magnetic resonance imaging, use extremely strong magnetic fields to align hydrogen atoms in the human body. Then, by sending radio waves and detecting the signals emitted back, computers reconstruct detailed images of organs, muscles, and even the brain, all without a single cut or X-ray. It's one of the most powerful diagnostic tools ever invented. Magnetism also helps us move faster than ever before. Maglev trains, which stand for magnetic levitation, glide above their tracks without touching them. They float thanks to repelling magnetic forces, eliminating friction completely. As a result, they can reach speeds over 600 kilometers per hour, quietly and efficiently. Magnetism is, in essence, the invisible engine of technology. It's what connects the motion of atoms inside a magnet to the global flow of electricity and data that drives our world. From power generation to transportation, from computing to healthcare, magnetism is everywhere, the hidden force behind modern progress. Magnetism doesn't stop at Earth. It stretches across the entire universe. Every planet, star, and galaxy is influenced by magnetic forces. The sun's magnetic field shapes solar flares and storms that can disrupt satellites on Earth. Jupiter's field is so strong it traps deadly radiation around the planet. Even in distant galaxies, magnetic fields help guide cosmic dust and gas to form new stars. Without magnetism, the universe as we know it would not exist. It's one of the great forces that shapes both matter and energy. But magnetism isn't just part of the past, it's also the key to the future. In laboratories, scientists are developing fusion reactors that use enormous magnetic fields to contain plasma hotter than the sun. If successful, they could give humanity clean, limitless energy. In transportation, magnetic levitation may soon power silent trains and even launch systems for spacecraft. And in computing, new magnetic materials are leading to technologies like spintronics, where data is stored using the magnetic spin of electrons, not electric charge. From the smallest atom to the largest galaxy, magnetism is everywhere, binding the universe together. It's the quiet, invisible force that powers our world, protects our planet, and connects us to the stars.